Вот, слышно. Замечательно. Надеюсь, все вернулись. У нас еще один классный доклад от Саши. Тоже про базу данных.
I hope we're all here when we are now going to have the presentation from Alexandra. She also grew at Yandex, but she now works at Positive. Hi, everyone. Now let's continue with the products that started at Yandex, and let's talk about ClickHouse. But first, let's get to know each other, and I'll get a clicker. I'm Alexandra, or Sasha Popova. I have been in data for the past 10 years, and this was fintech and medtech and retail, and now I'm in info biz, and there were always interesting challenges there. What we are going to talk about the ClickHouse, a short intro in case somebody forgot or has never encountered that, so that we have at where ClickHouse can be slowed down and how you can help it and what are the alternatives. Let's get started. ClickHouse is the distributed system for database management for data analytics. It went open source in 2016, and it is famous for its fast, stable engines and much of that many like, and it all of those things make it stand out, really. And we know that it doesn't freeze. Where can ClickHouse be used? These four are taken from the ClickHouse website, where they say that it will feel great in real-time analytics, where we wanted to calculate something in real-time mode. Number two, classical storages, and once a day or several times a day, we get the batches of data, and we build reports, and this works. Then you can use it as data in machine learning as a source to calculate pre-aggregates, use them in models, or as the storage for the models. In the ClickHouse itself, there are several implemented predicative models, and if needed, you can calculate using them. And the last thing is observability, and today we are going to talk about observability, and we'll talk about how ClickHouse is experienced. What is observability? Observability has logs, metrics, and traces. And logs are text-based records of discrete events that occur within our system. For example, there is an alert, a mistake, and the data from the alert are the timestamp and the report about the event. The metrics are numerical measurements collected from our system, and it indicates how it feels. What could be the metrics? The resource utilization, memory utilization, counters, gauges, histograms. So when we collect them, if we have historical data in the future, we can understand what is a normal state of the system and what is the system degradation, and so respond to it. And there are also traces. Traces show the interaction between the components and how the query travels between the services, and this is super important and relevant, and those records that track the journey of requests as they flow through distributed systems. There is a lot of data and still growing, and this has to do with the fact that the company is growing. We're adding new infrastructure and new apps. The company is growing, and so a lot of many metrics and traces are best when used together, when analyzed together. Now we can use to the main topic. How can you make ClickHouse slow down? A short intro. Now let's imagine we are a small company with an internal structure, and we are starting to put together logs and metrics and traces. We need to understand what's happening, and we choose ClickHouse because it looks good for our purposes. We read the documents and we study it, and we have a small cluster, and we think that it's clear about how the data increases. We will have the distributed click because we want to decouple the workload, and we started living with this. We started getting data. We have some analytics, but at some point we understand that we have predicted the data growth incorrectly. After 6 months, we want to grow. We want to add a new shard, and but we see that ClickHouse does not support automatic shard rebalancing. And sorry about that. Do something about that. What could we do? We could write something in a new shard, and this might result in misbalance in workload, and it will not help with reallocating the data. We will get again to 85% utilization. Yet another shard. What else could we do? We could try to pull the partitions manually. We have enough parts, and how many partitions, how much time, and how many tables, and do we have partitions there? And basically, you can have a framework on the top, and actually, this is what we did, and it is responsible for balancing the data. But it is about OpEx, and are we ready for that? Another thing to do, since we have a distributed click, we are using a distributed engine. On the side, we can export the data from the source cluster to the new cluster via add and search from select. This will not be performant on very large databases and will potentially incur significant I/O on the source cluster and use considerable network resources. And most likely we will do this successfully anyways, but we don't know when. But we need to analyze the data. What else could we do? ClickHouse has the TTL so that we can have the cold storage. We don't want to delete the data altogether. So what we could do, we could have the stream upload, but if an analyst comes over and says, I want to see the data for 2 months, and they launch this query, and on the one hand, the data from cold storage will have to be retrieved, and then probably we will not have enough space, ClickHouse, for this data, and everything will result in the manual work. And the next option is scaling vertically when it is possible, when you have unlimited resources, where you have petabytes of disks and petabytes on the disk and terabytes on the operational memory. And when we want to analyze analyze all the data together. And when we want to find the traces, the events, study an incident, and we launch a query, and we start waiting, wait a little bit more, and we are not clear about how long we will wait and if we'll get the result. Why this happens? Because the soft join is an expensive operation, because for each value, you will have to find the right value. And if the range is too big, then the computing complexity will be squared, and there will be competition for resources. Everything will be slowed down, and ClickHouse doesn't have inbuilt indices for join operations, and we have to think about what to do. ClickHouse likes wide data tables with logs, metrics, traces, and something else. But once again, this operation should come from the client, and the client should write in a wide table. Another thing we could do, we can write our select using just one table. That's cool, but what are the other options? We could also use the materialized views, and you can do time-wise according to the metric we need, but we've got to remember that the math view can generate a lot of ports, and also to generate a lot of issues, because it is about generating ports, etc. We're going to talk about that. But we create this match view, and the only thing we'll have to do is to join according to the strict inequality. And after some time, we are saying we want to find something in the messages, and we launch this, and we find something. But we have to wait, because by default, this is a very expensive operation. And why so? Because we have to scan every line, which is very expensive. And the bigger the table gets, the longer it will take to search. And ClickHouse has a lot of stuff, and it has the experimental index. This is the implementation of the standardized inverted index. I don't know how to say that in Russian. They create a structure where for each token or engram next to it there is a position or where a certain word occurs. We create this index, but creating this index will slow down the inserts. And if we look at our CPU and our RAM, we will have to monitor them all the time, and slicing this into tokens and parts is very expensive. And this is an experimental thing starting from 2023, and Yandex wrote in the press release that they have to rewrite ClickHouse, and then it is a secondary index that ClickHouse will use only after it has used up the first ones. Or you can also try and choose the Bloom filters. They exist in tokens, but this enables ClickHouse to skip partitions, but this is not a search according to a specific value, and Bloom filter will slow down our inserts, and it's not as fast as we want it to be. And now we are moving to the insert. We understand that we have a lot of data, and here is a little bit more about how the insert in the ClickHouse works. We have certain inserts, and ClickHouse puts all of that in the ports. Those are the sets of lines, and we have more and more ports, and the ClickHouse needs to merge the small files into big ones, and many people use that with Iceberg. And the merge is an expensive operation. Why so? Because you have to read the file again, and you have to do the decompression, then resort it, then compress and put it together. And if we have a lot of inserts, then we can run a mistake, which means that in each part of the table there are too many active parts, and this is what you get when there are 300. And for a ClickHouse, this is a way to say, now let's stop at that, now merge it, and then we'll continue. Right now I cannot do more than 300, and there are a lot of small files, and it always results to unoptimized reading, and there is always competition for resources. If we have something working on the background, what we could try doing, as ClickHouse recommends, inserts in batches anywhere from 10 to 100,000 entries. But if this is not possible, you can use a buffer engine. A buffer table is created in operational memory. It can keep the data and flush the data according to certain conditions, the timestamp and the number of entries, and it looks fine. But we also have to support the DDL of our destination and the buffer table. And if we add a new column, that's fine. The buffer table could insert the data in the overlap of the columns. But if we add team data, which is incompatible in the buffer table, and when we flush the data will be lost, and we will not even know that this has happened. Another interesting thing is that when we make a query to our target table, which is done by the buffer one. In the buffer tables, there are no indices. And if we have heavy analytical queries, they might slow down if the buffer is not chosen optimally. This will be really noticeable. And you've got to remember that the buffer table is in a framework, and this should somehow help. And yet another point is that if anything happens with our node, then our data will be lost. And what is the alternative? In the ClickHouse, there are synchronous inserts as an alternative to buffer tables. We will not have to support DDL ourselves, but they work similarly. The buffer is done in the operational memory, and then all of it is flushed to a single part. But again, there can be a number of nuances. The data validation and data parsing happens at the flush stage, and the data might get lost. The same situation with an urgent reload of our node, the data will be lost. And if an analyst creates a table where ourselves didn't do much thinking and chose the wrong key for partitioning, but anyways, we might run into too many parts error. So you have to be really cautious when you do the design. What else should we bear in mind? Not cloud native, and let me explain what it is. The ClickHouse supports scaling, and horizontally you could add shards, but this is always manual work and operational costs. And in ClickHouse, there is replication. That's cool, and this is robust, but we have to support it manually. And if anything goes wrong, there is no self-healing. It can not heal itself or scale up. So we said that we should do it on our own. And another thing is that ClickHouse does not natively integrate into the cloud, and it's not so easy to deploy it in a cube. Yes, it can keep the data in the storages, but that's different. As to the cube, there is the ClickHouse operator, and there are a lot of bugs and issues, but still there is some progress. And this is my personal pain. Open source seldom has good information, but for the ClickHouse, they don't have different versions, and it's hard to understand the functionality for each version, and then you have to track it and somehow back engineer that. That's my personal headache. Now, moving on to the alternatives, what could you try to explore and use? Let's see what is available globally. There is Snowflake, Google, BigQuery, Databricks, StarRocks, a lot of things. But what's in common between them? If you look at the architecture, we're looking at Snowflake. It has separately query processing and data storage, same for BigQuery separately, and similar for Databricks. Compute and storage are separate, and all of this leads us to a change in the architecture. Right now, everything is moving from the shared nothing, when the node structure is responsible both for the storage and processing, to the architecture where you have separately computing and storage. What could be the benefits. Number one, we don't have data redundancy because we do not support their application the way we did in Data House. We can scale up flexibly. We can add as much as we need. We can allocate and distribute workload. We can select different engines for different workload, and this unties our hands in terms of choosing a technology. And thinking about what technologies could be in the stack. This is data storage, object storage. Then we select the file format to keep our data in. Then we need an abstract meta layer and the table format from which we could select something. Then we need a meta catalog to work with the data, and to download the data, we could use Spark Wing for analytics, Trino and Jupyter. There are more and more available technologies. And going back to the ClickHouse, actually, they are trying to go into separating compute and storage. But you've got to understand when ClickHouse was created, it was about working with local disks and Merge 3 engines, and moving to a different architecture is really complicated. Right now, you could try to deploy this architecture when the disk is some object storage, and ClickHouse writes that you should think twice before doing this, and they suggest using the ClickHouse Cloud because there is an additional engine there, which is called Shared Merge 3, and it is available only there. And then what could be another nuance here, even if we deploy such an architecture, anyways, data upload would be slow, and some meta information anyways will be kept on ClickHouse's disks, such as indices. All of this will be kept on their disks. And then probably we could look at the cases about how the architecture changes. There is Influx DB. If you came across it, if you worked on graphs and various rows, and when this database came around, what happened? This was a monolith for storing and processing data, but then they decided to separate compute and storage, and compute for them is data fusion, and in the storage they have the data in Parquet. And the next case, which is very relevant for today, there is this company, CrowdStrike. It's an InfoBiz. Probably you heard about them back in 2024 when there was a huge Windows fuck-up because of the update of one of the products of CrowdStrike. But we are talking about a different thing, not the fuck-ups. In 2021, there was news that they were acquiring a startup called Humio. On the basis of this Humio, they created their own log-scale storage product, which is designed to analyze logs, real-time analytics, etc. And here it would be interesting to look at the architecture. And here it exists through Humio, but there are nodes which are responsible for this, and there are data nodes nodes that keep the operational information, and there is object storage too that we can use. And I believe it means that it's about separation again.
Okay, so the conclusions. The conclusions are presented as questions. ClickHouse is good, but it's only good when you can and want to use it. So before you switch to ClickHouse, please answer the next question. What is the amount of data that you plan to store? Do we need to scale? How quickly do we need to scale? What type of queries will be prevalent? Aggregation of data, filtration, difficult join operations? Maybe then we'll have to think about that, especially about types of filtration. Next question. Which requirements do we have towards the data and the speed? Or will it be in batches? Will it be streaming? And finally, do we have experience and resources to support ClickHouse in our team, in-house, so to speak? Well, that's it, basically. We've given it a thought, we've put our heads together, and that's the result. Thank you.
Что-то я задремал.
Спасибо.
I sort of fell asleep. Well, thank you for the compliment.
Из-за поезда.
Так, ну теперь вопросы.
Maybe because of the train. Okay, so now the questions.
Неужели
Questions?
нет вопросов?
I can't believe there are no questions.
Нет, на самом деле.
Oh, come on, you guys.
Было очень интересно, просто где-то в середине у меня начались общения.
Well, it was
Надеюсь, не алерт.
quite interesting. It's just that in the middle of your presentation, I switched to chat messaging. But anyway, I like the following part, that if one node not goes away, then we will lose the data. Is that based on the real events? Or? Yeah, it happened in my previous project. We used the buffer table, and we shouldn't have, because the ClickHouse doesn't like the buffer tables. The ClickHouse wants everybody to migrate to inserts, which actually can lose data as well. But yes, we did have incidents of that type. We have a question, I think. Женя, thank you.
Возились дальше, то есть пытались их оптимизировать каким-нибудь там.
Did you try to optimize the queries, the index queries? What? Partitioned one. Yeah, we partitioned that. We tried to do that. It speeds the process up.
Лучше не лезть. Особенно, когда у тебя много данных.
Ну это да.
But if you have a lot of data, it's better not to risk it.
Да, просто когда там
We have the same issue.
много терабайтные таблицы.
If you have a multi-terabyte table, it hurts.
Еще
It
вопросы?
hurts when it's lost.
Или опять мне спрашивать?
More questions, or should I ask one?
Ну, про потерю данных уже поговорили.
Okay, we talked about loss of data.
Скажи, вот там было про решардинг.
Could you tell us about resharding?
Не хотелось ли что-нибудь
Написать.
законтрибьютить для
Да.
решардинга?
Did you want to contribute to that?
Кажется, в клик это прям
To
супер
contribute to
сложно.
that?
Написать что-то сверху
It's
своё.
very hard to
На самом
contribute
деле,
anything to ClickHouse.
нужно,
To write something of
если
your own
постоянно
on top of it, yes, I think there is a need of that.
ClickHouse
If you are scaling all the time, and if your ClickHouse grows. So this is something that you should do 100%.
Такую штуку осилить.
Если было бы просто, она бы уже
Do you think it's hard to do that? I don't think it's easy. I think if it were easy, it already would exist and would be available in open source. Did you try to do it yourself?
У них там вообще
No,
какая-то
no.
сумасшедшая
I read an
интеграция
Uber
кажется.
write-up about that. They have an incredible ClickHouse installation,
Они на него потратили немало.
and they had to write something on top of it, and they spent a lot of time. on that, and we're talking Uber, right?
Нормальный бэкграунд.
They have resources, right, and a lot of background and all that.
Ну, просто кажется, что вещь
Right.
такая полезная.
Right.
кажется,
It looks
что
like it's a
она
very
должна
useful thing.
существовать. Странно, что
It looks like it should exist.
Ну, да, ClickHouse
But it doesn't.
Об этом
Well,
не сильно. Ну,
Yeah, ClickHouse doesn't want to talk about it about that, I think. At least they didn't think about it when they developed it.
Ну, опять
Будем
же, да,
надеяться,
это-
что она появится.
Ну, это
All right. Well, let's hope that it will
говорил про скоростное
come into
управление,
existence.
там, Google
Yes,
доверие.
it's
Нужно
open
понимать, что
source. I talked about
всё компании,
Google
и
queries,
все
snowflakes.
принципы приходят
This
к
is
ClickHouse
proprietary
с
stuff. We
они
have to
там
understand that.
выполняются Гучей.
And on the function that you have to make, to do rather manually in Click
Ну, если
manually,
перейти на ClickHouse Cloud,
is done by a
автоматически.
whole set of
На
people.
ClickHouse Cloud тоже нету.
If you go to
Я очень
ClickHouse
прям
Cloud,
всю
it's
секунду не могу ответить
pretty
на
much
этот
automated.
вопрос.
Интересно.
So it doesn't exist in
Ну, что,
ClickHouse
если
Cloud
вопросы
either? No,
появятся, то,
I can't tell
видимо,
you right now.
Женя
I
уйдет
don't think it
в
is.
Еще один или первый?
Okay, if there are no questions, then Eugene will get the prize for the only question. What about yourself? I've already got one.
Вот он.
Oh,
Спасибо.
okay, here we go.
Подскажи, пожалуйста, вы
thank you for your
напрямую
presentation.
данные или как-то их нормализуете?
Do you upload data into ClickHouse directly, or
Сию секунду.
no? We only use ClickHouse right now for DB storage. So it goes. So whatever you do goes directly into ClickHouse. Yes, it goes directly into it.
Возникают периодически всякие интересные истории именно с загрузкой.
Some issues are related to that about uploading to ClickHouse. The latest I recall,
Ну, по памяти, да,
I think we
вот
didn't
опять же,
stay within memory
было бы
limits.
потюнить.
Yeah, but we could have tuned it.
В общем, загрузка в клик тоже
Tuned it up.
интересная тема, про которую тоже
So
можно еще
uploading into Click is an interesting subject. Ingesting, so to speak, I think we can talk separately about that some other time.
Ну тогда у нас
Right you are. Okay,
вопросов нет? Можно...
if that's that,
О,
another question? Oh, good man.
Здрасте, спасибо за доклад. Меня зовут Илья.
Hi, thank you for your
Говорили
presentation.
про ClickHouse на Кубе,
This is my
я
question.
так понимаю, да? А был опыт вообще
You were
работы
talking about
на Кубе без
ClickHouse and
ClickHouse?
Kubernetes.
Или все-таки лучше на железках его?
Мы на железку всегда
Uh,
разворачивали.
where do you host it? We host it on the hardware. I don't think it's better to host it on hardware.
Требует активной
My own
работы с
experience
диском,
tells me this. Everything that has to involve
на железе.
the disk, I would store that. I would implement that on the hard drive. I mean, on
Может быть,
the hardware. I haven't seen ClickHouse and Cubers, but I think they're starting this. But personally, I don't know any companies where they
кажется, что слишком
who have
сильная
switched to
работа с,
Kubernetes.
диском.
Yeah,
Кажется, что лучше, чтобы она была условно с data locality, да, чтобы данные...
yeah. I think if you are using the disk a lot, the data has to be close to the computer.
Кажется, что с диском...
It has to be local. Yeah, I think it will get. It has more sense. I agree.
Так, так.
Давай.
Есть опыт?
Я не поддержу
Окей.
коллегу. В Linux, ну,
In Linux,
что кему, там виртуальная машина, что у вас железо. Это просто удобно.
container in Linux is, you know, it's
Ну, если у тебя
it's just
это, грубо говоря, все на одном хосте,
Да,
всё
это
рядом.
прекрасно, прекрасно. И у вас это просто процесс. Ну, что
it's just for comfort. But Camu or
просто процесс.
Container D, they're all processors.
Ничего почти не тратит. Это ошибка.
They
ну,
don't
плюс
use
только
much
в
power.
удобстве разворачивания, фактически администрирования.
Well, basically, the comfort of administrating.
С одного хоста, ну,
That's what we have, because it's very
здесь
hard.
ничего не выиграете, или я не прав?
I mean, if you have Kuber,
Тут нужен DevOps.
you will not
Как масштабировать клик?
gain anything if you try to scale a host from one host. Hi, my name is Sergey. I want to join this conversation.
Мы в разработке антифрода
I
занимаемся.
work in F6.
Круто.
We actually have ClickHouse in Kuber.
Скажем так, мы столкнулись
And how is it going?
с проблемами, которые здесь перечислены.
Well, actually, we've encountered all problems that you enumerated. How to scale it? Yeah, Yeah, we're doing it in batches.
делаются, но вот
Analytical queries, yes, but scalability is a big problem. So, yeah, we still don't know how to do it. And as I understood, there is no solution on the market.
Object storage.
I was interested in object storage.
S3 хранилище, куда база просто...
Are we talking about remote S3 storage where the computer basically deposits data? Oh, yeah. Yeah, it's an S3. It doesn't have to be remote. It has to be in your system, but it's got to be in object storage. But then again, we have overhead. We do have overhead, but for cold data, I think this overhead is allowable. Okay, so store the data which you don't need for hot queries, right? Something historic, right? Yeah, historic, or if you have a raw layer, you don't touch it very often, neither do your users, but you don't want to lose it, and you want to save on its storage. You can, I think, store it coldly. Well, if you look at what ClickHouse says, that there is a node for computer, there is a node for this and not for that, and it doesn't matter how often you use data, they are all placed into object storage. There are specific drivers or specific engines which can work with them quicker. It's not like... I think it has more better response times. They do try to make it quicker. They have an additional driver that allows you to work with metadata and with S3. So it'll go a little quicker than just dropping it into the cold storage and then going back. On the computer nodes, yes, you can cache, you can implement some data prints, right? And talking about the nodes, we also store meta information there, indexes or other structures, keys. Is there an example of practical use of that I could read about? I think ClickHouse provides some examples. I don't remember the company off the top of my head, but I think they only have one case to date. Okay, thank you very much. I liked your presentation a lot. Number of memes for me is the quality factor.
Добрый день, спасибо за
Hi,
доклад. Меня зовут
thank you for your presentation.
И у меня такой
My name is Victor.
провокационный вопрос.
I have a provocative
Получилось ли у
question, I
вас
think.
ваш в ClickHouse положить некорректной TDL-кой?
Have you tried to
В TDL query
basically to drop your ClickHouse with
query в ClickHouse
with an incorrect query, the query which was incorrect by default? Yeah, well, because we could kill
кластер
a node. No, the whole cluster. The whole cluster, no. But the node, yes. One incorrectly formulated query and off goes the node.
Я верю.
Okay, I trust you. Thank you. More questions?
Ну, теперь есть из чего выбрать.
Okay, now you can choose from.
Даже не вопрос, а просто сама ситуация, что вот у ребят развернуто.
I like the situation, not so much the question, but the guys implemented not ClickHouse in Cuba, and I think that the price should go there.
А книжка у нас, да?
The prize should go there. Do we have a book to give?
Убери.
Who asked about ClickHouse and Kubernetes? Thank you very much.
Тогда еще через 15 минут следующий доклад.
Okay, with this, we'll have a small break, and we're waiting for everybody in 15 minutes. Okay? The next presentation will be about SRE. Thank you.